Okay, so now we are emerging from the Younger Dryas, and now we're entering more modern days. So how has climate evolved over the past few thousand years? Now we're getting to a point where we actually have a little bit more evidence, not just temperature records, but also written and recorded evidence, stories from ancient cultures, from the Egyptians, from the early Chinese, um, from many of the Native American tribes living in living in what we now call the United States and Canada and North America. Um, and so we have a pretty good reconstruction of climate um, pretty much over the past 2 millennia. And let's see what that basically has suggested. So, over the past roughly 1500 years, we have seen a relatively various but pretty steady change in temperatures where we kind of wiggled between roughly half a degree below current values or below the 1961 to 1990 average. And then we had a little period of cooling right here known as the Little Ice Age. And then roughly since the Industrial Revolution, we have began to notice a very rapid warming period. A very rapid warming period. So let's break this up a little bit and talk about it. So, over the past 1,000 years, temperatures and observations were obviously much more accurate and detailed than what they've been in the past. So we haven't had to just rely solely on proxies. We've had other things that we can kind of lean on as well. And so we have a much better piece, a much better taste of how climate has varied over approximately the past 1,000 years. So in the year 1000, or in the 1000s, also known as the 11th century, things got kind of warm. We entered what was called the medieval warming period. In the medieval warming period, from roughly 1000 AD to about 1400 AD, so those first roughly 400 years, 1400 AD, so roughly those first 400 years of this past millennium, we were in a period of warming. During that time, Greenland actually became a somewhat attractive place to live. And the Vikings, who were on their world tour, they had hit up Iceland, Denmark, other parts of Northern Europe, settled in Greenland, and they grew and they thrived there. Then the Little Ice Age came. Temperatures began to cool again, and those same Vikings died. Bye-bye, Vikings. Greenland was your last stand. I'm so sorry. I hate to break it to you. The cooling, however, was not worldwide. It was mostly concentrated in North America and Europe, very similarly to the Younger Dryas. So it's very possible that what happened during the Younger Dryas also happened during the Little Ice Age. So let's talk about that. What may have caused the Little Ice Age? So the Little Ice Age was approximately 1400 to 1800 CE. That's also what we refer to as AD, the Common Era. The cooling was not world, mostly concentrated over Europe and North America. There are a few prevailing theories as to what possibly caused this. There was actually a very coincidental thing that happened in the early 1600s, where sunspot activity actually declined quite a bit, and that could have caused cooling. That was actually what was referred to as the Maunder minimum. However, this Maunder minimum period was only about 50 years long. It's only about 50 years long. It wasn't, and as I mentioned, this cooling was not worldwide. It was mostly Europe and North America. Other parts of the world did not see the same cooling. If the modern minimum was the reason why this cooling was happening, it would have been experienced worldwide. Not only that, but there's a lot of evidence that suggests that solar activity only makes up a tiny little bit in climate variability. And we'll actually cover that in a few weeks when we talk about natural climate changes and radiative forcings. So we saw a substantial decrease in solar activity. That is one of the possible explanations, but really most likely not the big one. The big one is right here, the shutdown of the thermohaline conveyor. I kind of talked about this a little bit in the last module. If you've ever seen The Day After Tomorrow, it is literally the only piece of science in that movie that actually makes sense. Everything else in that movie is a piece of fiction, and depending on your taste in movies, it might be a piece of something else as well. But let me make sure to at least do the modern minimum some justice. So basically what happens is we experience what is called a, whoops, I don't know why that happened. Basically what we have experienced is an 11-year cycle of sunspot activity where sunspots go up in number and then down in number, and then up in number again, and then down in number again. Well, for whatever reason, roughly between 1650 and 1700, there was a substantial decline in the number of sunspots. Now, the number of sunspots is directly related to solar output. The fewer the sunspots there are, the less intense solar radiation is, the less intense sunlight becomes. However, we're actually talking about less than 0.1% of variation. So this isn't really a big difference. But it is worth noting that that actually did happen during part of the Little Ice Age. So it is worth at least mentioning that that is a possibility, that roughly during that time period, we may have actually seen a little bit of a cooling period because of decreased sunspot activity. But again, this is not enough to account for, one, why cooling was so significant, and two, why was it mostly over North America and Europe? Well, the next thing can explain that. The next thing is what is referred to as the thermohaline conveyor. So I know it's easy to look at this and feel like a deer in the headlights. When I took physical geography my freshman year and I saw this, I said, holy crap, what have I signed up for? But it's actually not that bad. So let's talk about what happens here. So what actually happens here is Earth's whole ocean experiences this large global circulation that is a function of temperature, hence thermo, and salinity, how salty the water is, hence haline. So it's known as the thermohaline conveyor. It is a ocean current that is fueled by differences in temperature and differences in how salty the ocean is. Well, here's how it works. Right up here, a very, very, very important component of the current is right here. Right here, warm ocean waters from near the equator make their way up along the North American coastline in a current a current that we refer to as the Gulf Stream. As that current then makes its way up to this area in between Great Britain, Ireland, Greenland, and Iceland, it gives off all of that heat. It gives off all of that heat towards Europe. This makes Europe nice and mild. Well, what's left behind, though, is a very cold, salty, briny body of water. Well, cold, salty water sinks Don't believe me? Get 2 cups of water, get one of them just fresh water, take another one, put a few spoonfuls of salt in it, and then dye it a color, like a blue color, and then pour it into the other cup, the cup of just fresh water. And you'll notice that all the blue salt water, when left alone, it'll just sink to the bottom. The same thing happens here. Well, here's the concern. We have seen a lot of warming recently. All of that warming is causing ice sheets on Greenland to melt. Those melting ice sheets are then dumping right into that area where the sinking occurs. This is diluting the water and it's slowing down the flow. It's actually believed that the Younger Dryas period, which was also mostly over North America and Europe, actually occurred because as the Earth was rapidly warming up, as it was emerging from the Pleistocene epoch, as it was emerging from that previous glacial period, all of the ice over North America and Europe was rapidly melting and over Greenland, and it was dumping right into that portion of the Atlantic Ocean. That shut the current down. And by shutting the current down, it stopped a heat transfer from the equator up to North America and Europe, making North America and Europe colder. Making North America and Europe colder. A very similar but not as drastic phenomenon is believed to have happened after the medieval warming period. After the medieval warming period, it was nice and warm in Greenland. It was warm enough to where we actually had Vikings populating Greenland. Well, during that same time, all that melting ice dumped into the North Atlantic, slowing the current down, and that slowed down the heat that Greenland was receiving, and that actually caused Greenland, North America, and Europe to go cold again. Now, it wasn't nearly as drastic as what happened in the Younger Dryas, but it was still something that made us go, wow, this is a pretty big coincidence. We see a spike in temperatures. Greenland melts, ice in North America melts. It dumps out into the North Atlantic, and it shuts this current down. Well, right now, while the whole world is mostly warming up with some exceptions, that little chunk of North Atlantic has actually been experiencing record cold. Now, this is still a postulation. We're still there's some evidence that suggests it, but it's still very much a hypothetical what if kind of thing. We're not 100% sure if this is actually what happened. But if it did, it could happen again. And as Greenland is melting, it could shut down the thermohaline conveyor again. And that could make at least some parts of Europe cooler than they currently are. Now, the good news is that may actually offset a lot of the warming that we've experienced. Maybe that makes Europe a little bit more mild than much of the rest of the world. But if it ends up being a really drastic shutdown, it could throw parts of Europe back into a Younger Dryas-like ice age, and that would force a lot of people to suddenly have to migrate quickly or die. So that is something that we are concerned about. Now, just like a shutdown of the thermohaline conveyor can cause dramatic shifts, or just like the eruption of Lake Toba or the Yellowstone supervolcano, we've also had our own recent cataclysmic events. In 1815, the eruption of Mount Tambora in Indonesia, another Indonesian volcano, erupted. This was an eruption that was only 1 order of magnitude lower than the Toba eruption. This eruption was capable of ejecting over 100 cubic kilometers of ash, whereas Toba and Yellowstone, 1,000 cubic kilometers. This put a lot of sulfur dioxide into the atmosphere. Sulfur dioxide is very, very, very reflective. And so sulfur dioxide reflected a lot of sunlight, and this triggered a period in 1816, the year after the eruption, known as the year without a summer. And during the year without a summer, we actually saw instances of ice and snow and winter-like conditions in August and in July. Now, if you're like me, I'm a polar bear. I'm built for the cold. I love the cold. I'm cool with that. However, if you're a farmer, guess what? Your crops are failing. They can't survive in that. So this led to a major global famine. This also led to a major global slowdown in development. It also led to a major global slowdown in development. Now, that being said, this all talks about temperature and other things that happened. What about our good friend carbon dioxide during that time? Well, now I'm showing you what is referred to as the hockey stick. Basically, carbon dioxide concentrations over the past 10,000 years have been relatively stable, pretty much hanging around that 280, 260, 270, 280 parts per million range. They've wiggled a little bit, but then right around the 1800s, whoop, they have shot up. They have shot up substantially. So how is this, or what kind of warming has this caused in recent times? Well, we will talk about that in the concluding video of this module.